Okay, let's see example for the curve and divergence. We have this vector field. The formula to compute the curve is partial derivative q with respect to x minus p partial derivative p with respect to y. In our example, this is p, this is q. So say partial derivative q is y with respect to x is 0. P is this partial derivative with respect to y is 0. Is 0. So that means that this vector field is conservative. Divergent of the vector field. The formula is partial derivative p with respect to x and partial derivative q, no p, with respect to y. The partial derivative p with respect to is 1, partial derivative q with respect to y is 1, and 1 plus 1 is 2, is positive. That means that this vector field not rotate, never rotate, and always is source. So at one point we have more output than input. Let's see more clear in one simulation in GeoGebra. Okay, this is the graphic representation of this vector field. It's totally radial, x, y, and you can see at any point, the divergence is 2 and never rotate. And to indicate the rotation, we have a small wheeling and never rotate. It's a wheel, never rotate. Okay. Okay. Again, the same idea. You determine the curve of this vector field. Okay, the formula is qx minus py. This is p, this is q. In our example, partial derivative q with respect to x is 1 minus partial derivative p with respect to y is negative 1. So it's 1 plus 1 gets 2. And these two indicate it's constant, independent of the position, and always the rotation is counterclockwise, like that. Okay. And divergence of f is, the formula is px plus qy. Okay, derivative p with respect to x is 0, plus derivative q with respect to y is 0, no source. Let's see one GeoGebra simulation for this vector field. Okay, this is the second example, GeoGebra simulation. You see the divergence is 0 in any point, always is 0, no source, and the curve is 2. And you see how this is rotating counterclockwise. 2, look here, 2, here, 2, rotation. Of course, it's not conservative field. Okay, example 3 is another vector field. In this case, one more time, we compute the curve. The formula is partial derivative q with respect to x minus partial derivative of p with respect to y. This is p, this is q. In our example, partial derivative q with respect to x is 1. Partial derivative p with respect to 1. 1 minus 1 is 0. Okay, conservative, no, is completely irrotational vector field, no rotation. Now divergence is partial derivative p with respect to x plus partial derivative q with respect to y. Partial derivative p, okay, this is p with respect to x is 0, plus partial derivative q with respect to y is 0, 0 plus 0 is 0. So again, no, 0 above So that means zero divergency is no source. Okay, this is the GeoGebra simulation for the example 3. No? In this case, the curve and the divergence is zero in any point. Look, no source, no rotation. Example 4 now. This is the last of the 2 dimension. You compute the curve. Remember the formula is qx minus py. This is p, this is p, this is q expression. But the partial derivative is with respect to x is 1 minus, and partial derivative p with respect to y is negative 1. X2. We have rotation counterclockwise. Divergence of the vector field is px plus qy. Px is p. Partial derivative with respect to x is 1 plus partial derivative with respect to y is 1 also. 1 plus 1 is 2. We have source. Let me see in GeoGebra the simulation for this vector field. Okay, in this case, example 4, diverges 2 and curves 2 independent of the point. Look. And you rotate always counterclockwise. Okay, super fantastic.